Hey, 7th graders, you need to make sure you have your 1.6 multiplying and dividing integer notes out. Our job today is going to be to answer how do we multiply and divide integers. So we are moving on to goal 1.6, which is I can multiply and divide integers. So what you need, again, to make sure you have out are your notes. And one thing that I need you to get out that's kind of special that we haven't used in a while is a calculator. Just for this first part, okay? So pause the video, get your notes, and make sure you have a calculator. All right, so what I want you to do is these problems that you see up here in front of you and are in your notes, I would like you to figure out the product or the quotient using your calculator first. So I'm gonna have you pause the video again, figure out the product and quotient for the problems in that first chunk in your notes, and then come back and check your answers with mine. All right, let's check those answers. So 4 times 2, the product is 8. 3 times 12, the product is 36. 36 divided by 6, the quotient is 6. 48 divided by 8, the quotient is 6. You might go, Miss Kluver, I've worked on that since 3rd grade. Absolutely. Again, a reminder, don't lose what you already know about multiplying and dividing integers. Now over here, we're bringing in some negatives, right? -7 times -3. Notice that 21 still goes with it. Right? But now we have to ask ourselves, is it positive or is it negative? In this case, -7 times -3 gives me a positive product of 21. -11 times -5, positive 55. -14 divided by -7, positive 2. -32 divided by -4, positive 8. So if I look at this, and I'm going, okay, well, here, both of my terms are positive. Here, both of my terms are negative. So it's like the terms agree here, they're both positive. The terms agree here, they're both negative. My product and my quotients are all still remaining positive. You'll see that you have a box on the bottom of these problems, and it says when the signs agree. Do the signs of these terms agree here? The signs are either positive or negative. Yeah, they're both positive. Do they agree here? Yeah, they're both negative. So when the signs agree, the answer is positive. Write the word positive in there. Another way to say it, when you have an even number of negatives, the answer is positive. So more so focusing right here, I have 2 negatives. 2 is an even number. My product is going to be positive. Let's go over here to these ones. 2, positive 2, which I can just say 2 times a -3 is a -6. -8 times a positive 4 is a -32. -27 divided by 3, the quotient is -9. -49 divided by 7, the quotient is -7. And you might go, well, this time, Mrs. Kluver, there's only one negative in each one of the multiplication or division problems. And I'm going to say, yeah. Look at the box in your notes. When the signs disagree, they can't find a consensus. Here I have a positive, here I have a negative. Do they agree? No, one's a positive, one's a negative. So when the signs disagree in the problem, the answer is, what do you think? Negative. When the signs disagree, the answer is negative. Fill negative in your notes. Another way to think about it is an odd number of negatives, the answer is negative. Here I only have one negative in my problem. Is 1 an even or an odd number? Odd. So the product or the quotient is going to be negative. And you might go, how does this work, Mrs. Kluver? So I'm going to do 2 examples over here. This one right here models -7 times -3. This one right here models 2 times a -3. Okay, do a little squiggly line here. So take away 7 groups of -3, or using the commutative property, I can go take away 3 groups of -7. So there I took away 1 group of -7, there I took away 2 groups of -7, taking away a 3rd group of -7. When you have 2 minuses directly next to each other, what do they simplify to be? You're taking away the negative, so really this is plus. This is plus. Plus, what's 0 plus 7 plus 7 plus 7? Positive 21, right? And down here we have 2 groups of -3, or you can think about it like take away 3 groups of 2. I'm going to think about it like 2 groups of -3. So what's -3 plus -3? You're taking 3 steps further from -3 to the left on the number line. Where would you be? -6. When the signs don't agree, the product or the quotient is negative. When the signs agree, the product or the quotient is positive. So yes, these are really nice ways to just remember, quick and easy, but here's the math behind it and why it works. Let's go to the next part in our notes. Now, no more calculator, so put the calculator away. If you need to pause the video and get it out of sight so you're not tempted to use that, please do so. All right, down in the second chunk in your notes, 2 times a negative 6. We know the answer is going to be 12, right? But is it a positive 12 or a negative 12? Do the signs agree? No, they don't. One is positive, one is negative. So it's going to be a negative 12. Number 2, negative 8 times negative 8. We know the answer is 64, but is it positive or negative? Do the signs agree? They do, right? Or there's 2 negatives. Is that an even number? Then my answer is going to be positive. So it's a positive 64. 0 times a negative 17. We know the answer is 0. But is it going to be positive or negative? Don't let me fool you here. You know it's just 0. There's no such thing as negative 0. Remember, 0 does not have an opposite. It's that neutral spot on a number line. It separates the positives from the negatives. Here's number 4. The temperature dropped 5 degrees Fahrenheit each hour for 7 hours. Use an integer to represent the total change in temperature. So we want to figure out the total change in temperature, what integer represents that. So the integer that represents the change is blank. Helps me stay on track when I'm marking that text. Let's read line by line. The temperature dropped, there's a key operation word, 5 degrees Fahrenheit each hour for 7 hours. So every hour, minus 5, plus minus 5, plus minus 5, plus minus 5, plus minus 5, 7 of them. Repeated addition is the same as multiplication. So this is multiplying the degrees it dropped for these 7 hours. So 5 times my 7, it's a negative 5 because it dropped, right? So minus 5, the drop of 5 degrees every 7 hours, what does that equal? Well, do the signs agree? No, I have a negative and I have a positive. So that means my product is going to be negative. So negative 35. The integer that represents the change is negative 35. So we have more multiplying integers, but this time, look what I'm bringing in. We're going back to our order of operation days. So we have negative 1 times 3 times the absolute value of negative 5 times the absolute value of 2. In your notes on the back there in the left, I want you to write this. Absolute value bars are grouping symbols. Write that on the left side of your notes here. Absolute value bars are grouping symbols. So in our checklist with order of operations, we do grouping symbols first. So we're going to start right here. What's the absolute value of negative 5? 5. Now we bring everything else down. And we start again. I still have a grouping symbol because it's the absolute value there. What's the absolute value of 2? 2. It's how far away 2 is from 0 on the number line. Drop everything else down. Remember, be mindful of how you're bringing it down. Then we start again. I'm left with just multiplication. So I can chunk it, I can work through it however I want because commutative property says the order doesn't matter when you multiply. So I'm going to do negative 1 times 3. Do the signs agree? No. So my answer is going to be negative 3. And then 5 times 2. Do the signs agree? Yes. So it's a positive 10. Negative 3 times 10. Do the signs agree? No. So my answer is going to be negative. And then just go 3 times 10. Negative 30. Nice work with that. Recognizing that absolute value is a grouping symbol. Here's our next problem. If at any point you need to pause the video to catch up with writing in your notes, please do that. And you can always rewind the video to help you out too. So we're going to take care of our grouping symbol first here, the absolute value. What's the absolute value of negative 2? 2. Drop everything else down. Remember, there's a lot of invisible multiplication going on. Negative 3 times negative 1 times 2. So we could focus, we could do all of this at the same time, or we could do this right here. I'm going to choose to do all of it at the same time. You could go like this. Do the signs agree? Yes, so your answer is going to be positive here, right? It would be a positive 3 times 2, 6. Chunk it up if you need to. All right, let's go to the next 3 examples. I think these are our last 3, right? Now we're going to focus on dividing integers. So still dealing with multiple operations, so we got to bring in order of operations. Here I have a grouping symbol, which is absolute value, so I'm going to start there. What's the absolute value of negative 28? 28, yes. Now be very careful. Do you see there's a subtraction sign on the outside? Yes, so be very mindful that when you bring it down, that negative still needs to stay there. I'm not saying the absolute value of 28 is negative. That negative was on the outside. I got to drop it down. Negative 27, negative 28 divided by 7. Do the signs agree? No, they do not. So my quotient is going to be negative. 28 divided by 7 is 4. So negative 4. Over here, negative 63 divided by negative 7 times negative 3. We have multiplication and division. We got to work them from left to right, right? I don't have any grouping symbols. I just have those two operations. And when we are dealing with both of them, we got to work them from left to right. So starting right here, negative 63 divided by negative 7. Do the signs agree? Yes, they do. So I know the quotient is going to be positive. It's going to be positive 9. Drop down what you haven't worked with. 9 times a negative 3. Do the signs agree? No, they do not. So you know your product is going to be negative. 9 times 3 is 27. So negative 27. Number 9, here we go. What integer and 6 have a product of negative 54? So what integer? We have to figure that out. What could we plug in place for a number we don't know yet? A variable. So product is multiplication, right? So it's a variable times 6. It has to have the value of negative 54. So we could write it like this. 6 times something equals negative 54. Now, what could we plug in for x? Or what could we plug in for whatever variable you used so that when we multiply it with 6, we get negative 54? Well, think what times 6 is 54? 9. But we need our product to be negative. So 6 and 9, do they need to agree with their signs? They need to disagree with their signs in order for our product to be negative. So we need to make sure that we plug in a negative 9. There we go. So when we're multiplying and dividing integers, we want to pay attention to the signs. Do the signs agree? If they do, it's positive. Do the signs disagree? Then the answer is negative. When it comes to absolute value mixed in our problems, where we're going to need to use order of operations, we want to remember that absolute value bars are grouping symbols.